With its hot summers and extremely cold winters, Canada consumes almost 600,000 gigawatt-hours of electricity a year. And 15% of all that energy comes from splitting atoms. Nuclear power is cheap and clean. The tricky bit is keeping it safe. So, how do they do it? For the 4,000 people who work at Bruce Power here in Ontario, Canada, cleanliness is an obsession. Each day begins with a quick sniff under the arms from a highly sensitive electronic nose.
Clean, don't forget your badge.
But it's not BO they're worried about here, it's radiation. Because Bruce Power isn't some Australian superhero, it's one of the world's largest nuclear power plants. Covering more than 9 square kilometers, Bruce Power has 8 nuclear reactors, each capable of generating more than 750 megawatts of electricity. Altogether, that's enough to power a city of 5 million. And today is a special day, because the guys at Bruce Power are refurbishing 2 of their nuclear reactors. And that means that for the first time in almost 30 years, we're allowed in to see the bits you never normally get to see. The bits that are usually tucked safely behind 2 meters of solid concrete and a nasty-looking no-entry sign. Giving a nuclear reactor a makeover is a multi-billion-dollar job. So they turn to the top man, Bruce Power CEO Duncan Hawthorne.
The key challenge, I think, is being able to disassemble a reactor core that's been in operation for 25 years. That involves disassembly of a lot of irradiated components. Clearly not a task that we could send men in to do. It required the development of first-of-a-kind robotics.
Send in some fragile humans to do a job like this, and they'd soon turn the same colour as Homer Simpson, only with less hair. So a team of custom-built radiation-proof R2-D2s were drafted in and given their orders remotely from the power station's re-tube control centre. With the radioactive tubes removed from the core, they tell us it's safe to go in. The reactor core is the big round disc with holes in. To be on the safe side, anyone who goes near it must wear these chunky protective suits. If the core was fired up, these suits would do you no good at all. In a matter of seconds, you'd be toast. Once the reactor core has been checked, cleaned and rebuilt, it'll be time to fill her up again with some magic uranium. Uranium is found in dark rocks known as pitchblende. But these rocks are less than 1/4% uranium. There's a lot of crushing, dissolving, leaching, filtering and drying to be done before they end up with enough natural uranium to use as nuclear fuel. The uranium is then packed inside half-meter-long rods made out of a heat and corrosion-resistant metal called zirconium alloy. And the rods are welded together like bundles of sci-fi firewood. Each of these uranium fuel bundles can produce enough heat to generate 1 million kilowatt-hours of electricity. So you might be wondering why these guys are mad enough to be manhandling them in such a carefree way. It's because at the moment these bundles are only giving off tiny amounts of radiation. To make them zing, they need to be inserted into the reactor core. The 480 tubes in the core can each contain a dozen fuel bundles. And when all 5,760 bundles are in place, the stack starts cooking. Stand well back. Some of the uranium atoms inside the fuel rods are a bit excitable. When they get excited, they start throwing off neutrons in all directions. The tiny neutrons can pass through the zirconium walls of the fuel bundles, flying from one tube to another until they hit another uranium atom. When they do, the atom splits, releasing energy. And even more neutrons, and you have a colossal nuclear chain reaction. Of course, the thing about nuclear chain reactions is it's good to be able to stop them. Otherwise, you get what scientists call a nuclear meltdown. That's when Bruce Power sinks down through the Earth and emerges again on the other side of the world. Only kidding. In fact, the guys in the control room are very relaxed. Not only is the reactor sealed within 2-meter thick reinforced concrete walls, it also shuts down automatically if the temperature rises or the pressure drops too quickly. So there's not enough kapow to blow the roof off Bruce Power, but there's plenty enough to generate an immense amount of heat. The heat is used to turn water into steam, a process they monitor carefully from mission control. These massive turbines, laid out in the 400-meter-long, 20-story tall turbine hall, turn the steam into electricity. Like a violent steam storm spinning a supersonic windmill, the turbine revolves at 1800 RPM, driving a generator. The giant hamster wheel converts the movement into over 750 megawatts of electricity, enough to meet the needs of 500,000 people. Which leaves one niggly little problem: radioactive nuclear waste. After a year or so in the core, the fuel bundles are spent, but they're now extremely hot and radioactive. They're so hot, the rods have to be stored in water for 10 years before they can be safely disposed of, as Environment Manager Doug Borum explains.
We put them in these pools to actually allow them to cool down in temperature and also allow the radioactivity to dissipate.
This 8-meter deep reservoir has over 730,000 radioactive fuel bundles sunk in its depths. So the next time you turn on the toaster, spare a thought for the pool cleaner.